Hello and welcome to any combo lords joining me there. Nice to have you here. And I hope that anyone in the present tense is having a good day, and anybody in the future tense is ready for some fun number facts after some brief hellos and such. And what we are doing a stream in the room today for, well, it has to be in the room because it's raining outside currently, but what we are doing a stream in particular for, and let me see, I guess we still are seeing more than we need to do over there. Today we have recently passed a random looking number of subscribers that's actually quite interesting. 94249. It's interesting in multiple ways, a few of which are stuff that we can find online, and one of which I want to clarify that I didn't see written anywhere online that makes this particularly special out of this list, and under some other criteria would be the only member of these first four numbers on the list out of these that would stay on the list. So, what is special about this number that makes me inclined to do something interesting about it? Well, we can notice that these numbers are palindromes. However, a lot of numbers are palindromes in our base. And for example, here is a list of the palindromes in our base. Well, the first ones, there's an infinite amount, but as we can see, 676 was tucked on there. It got the shout out in today's title more than 666, even though 666 is a fun number and is triangular. 676 got the shout out today, and then the next one didn't until a while later. The next one is a quite meme-looking number, but actually is the second item on this sequence, which was here, 69696. And then we get to 92429. So why out of all of the palindromes I could have picked in our base are these ones special? Well, being palindromic is a base-dependent trait, and while that's interesting, it's not going to be enough with the amount of them there are and the base dependence of that trait for me to entirely name an episode title or live stream title about that. These numbers also have a base-independent trait, a trait that would be true of that amount of item however we wrote them. And when we have a separate trait about a number in a combo with a separate base-independent trait, sometimes we can get a quite narrow list by looking for these combos. Basically, things that have two specific traits on two lists that could be vast lists. Sometimes the crossover is relatively small. Now, there's actually not only a crossover, but a third factor we're going to have to add to make these numbers the exclusive ones we're talking about out of the palindromes. But the first eliminating factor we're going to note is that what's special about the number that was first in the title? The first one was 676. Well, this number happens to be, well, you might think 666 is unlucky to some people or cursed or something, but how about this one, 676? Because it's what you get if you take 13 times 2, and then 13 is unlucky in some American cultures, and then you square that result. 676. It is 26 squared. Square numbers can also be constructed many other ways, like that makes it the sum of the first 26 odd numbers automatically because of a property square numbers have. And what else is interesting about this? Well, there are other palindromic squares that weren't on our list. For example, 11 squared makes 121. That's palindromic. Even on a trivial level, we could say that 1, 2, and 3 squared each would make another one-digit number that we could call palindromic. But even many others here, if I take, how about 111 squared? 1, 2, 3, 2, 1. Why is that not on our list? Well, in all these cases, not only was the square number palindromic, but so was the number we squared to get it. What about the case of 26? 26 is not a palindrome. It reads different backwards, but its square is palindromic. And now if we look at the crossover, which will be slightly, let me see if that's the right one here, yeah, of palindromic squares in general. This is a full list of palindromic squares, but the n here isn't what we squared to get them. N is just which palindromic square it is, if we could call 0 the first one. And with these palindromic squares, we do notice some interesting jumpiness in the digits. No 2-digit ones or 4-digit ones. We also would have a shorter list if we said, what are the palindromic squares on this list that the number that we squared to get them, in other words, their square root, was not palindromic, but which squared gave a palindrome? Now, they to a degree have that here. They have on the OEIS, this classic resource of sequences. They have numbers that are not palindromes, but whose squares are palindromes. This is the root of them. They didn't have an exact list for the numbers that are the square palindromes whose roots aren't. The other way we could take it, which would be the squares of these. But they do have something similar we'll look at in a minute. But here we'll notice that these numbers are not palindromes, but their squares are. And when we get up to the square of some of these numbers, it starts getting really big. So what's 2285 squared, for example? That's this big thing. And in fact, that is the next item on the list. After the 4 in our title, this is what would have been 5th in the title if it wouldn't have clogged up the title too much. So these numbers are quite interesting, but we're going to be able to limit it even a little more, because this already is an interesting list. What this gives us are the first items when we square them on this list, perfect powers that are palindromes, while the root of the perfect power is not a palindrome. Now here's the thing. Cubes don't show up on here until I think about this one, that it's any perfect power that's not also a square. All of these are some sort of square number before. And then this is a cube. But these first ones, at least these first 5 here, are items on our list, because these are all the square ones that are square number palindromes. That crossover trait that they both have the base independent square number trait, and in the base we're stuck in, happen to look extra neat by this backward property, being backwards is the same as forwards. And we will talk more about palindromes in general a little later in this stream. Well, if we make the extra exclusion that we don't want the root to be palindrome, we only want to get the palindrome once we square a number. Well, here's our list, and if we were talking about in terms of subscribers we're going to pass, we got not extremely hard to pass if you work hard on a channel for a year. Wowie zowie, we passed these awesome ones, which we will talk more about in a minute. We will get here someday. Hopefully we will get to this one as well. We'll see. But it's going to be a while till the next one. That is more than 500,000. So this is our last perfect power palindrome whose root wasn't a palindrome for a while. Of course, this is just in our base 10 system, Anybody can feel free to try and investigate and let me know if, what the other numbers that would be on this list would be if we counted in a different base. Now, there are extra traits we can get about these. But first, let's note that this list is almost all numbers that are a square number. There's only one that's a cube number on here. Because normally, to be a cubic palindrome, your root is a palindrome as well. And there is one exception mathematicians have found. I have mentioned this in a short, as well as this will momentarily cross over into some things I already went into in a main channel episode called The Perplexing Patterns of Palindromic Numbers, which is actually one of my favorites on the main channel. Definitely check that out after this stream if you want to see other stuff about palindromes that I'm not going to say here because it's already in the episode. But one thing I need to mention that was in there is that the number 2201 is really rare in our base. This number cubed is palindromic, and it isn't palindromic, 2201, but its cube is, and it is the only number discovered in our base like that. We have been unable to prove, mathematicians, that it's the only one, but a extremely large amount of numbers have been checked, and this is the only one discovered. It's unknown if there are any other numbers with that property. As for squares, there are other numbers with that property, and they're this list. As well as, well, this is the roots, and then we could also look at it in the square form. Now, there is another interesting thing I can note about today's. And, wait, I need to plug this in. What I can note about today's, and let me just hack onto the chat for a moment while I plug this in, and then I'm going to explain why we can make today's even more interesting than the rest of the list, if we want. So, today, we are at right past 94249 on this list, and out of the ones on this list, we can see it looks a little different. This one up here looks a little different as well, but we can sort of see almost like a family. 676, 69696, 698869, and 4. So does this down the line, 2636. But this really stands out, 307. Now, this one also looked a little different because it was odd. The fifth one was this. Looks a little different than these because it's this other odd thing. These ones look, although this looks a little different, they are all even. This one also, although it looked different, is definitely a multiple of 5 due to its last digit. So when I saw this, it made me wonder, wait a minute, 307's a prime, isn't it? And I looked it up, and it's true. 307 prime, yes. So when I checked later, I was like, wait a minute, yeah, none of these are primes. That can't be prime, that can't be prime, that can't be prime. This one's digits add to a 3-even number, so it's also 3-even, so that can't be prime. That can't be prime. And I went down the list a while, and it's not until a bit later, I forgot exactly which one. If someone in the chat wants to let me know, which one of these is the first prime on this list after 307. Let me know in a comment if anyone wants to check those real quick. And not by hand, using online help, or by hand. And you can check these by hand and let me know 5 streams from now once you've figured out which ones are primes. But I know it's not until way later that we hit another prime. And these ones have such big squares that those are going to be way bigger than an amount of subscribers that is manageable to pass. That's the squares of these are bigger than the amount of people on the planet. And so this number, 307 squared, 307 squared, just to show it in action, 94249, palindromic in our base, is, well, this number to be specific, the 9422491, is the only achievable subscriber amount that is palindromic in our base, but whose square root is not palindromic and additionally a prime. So that's pretty neat, huh? So we are there. Time to call it quits. No more combo class. We have passed the only achievable milestone. Just kidding. If we look at the list of interesting numbers on Wikipedia for 90,000, they do mention this one. They don't say all the stuff I said. They just say it's a palindromic square. Someone should edit this Wikipedia page to say that it is the only palindromic square whose like less than some massive size, whose square root is a non-palindromic prime. And did you guys just see that cat jump in the window or not? I don't know if that was visible in the background, but Sage just jumped in the window. Hey Sage, come. Maybe he'll come back in a minute. And D-Lion's usually the one who likes sleeping on the bed here, so maybe he'll come back all soaking wet because it's mildly raining and they still like going outside. So, as we can see on this list, in terms of what I will half-jokingly name other subscriber streams as a protest to subscriber streams only being base 10 numbers, we will... and you know, it's half a joke, half an excuse to spend a long time talking about a type of number. We may go into this. Capricorn numbers are actually different than the certain Capricorn constants some people like to talk about, which are, this is sort of the less of the cool things of the Capricorn type of numbers, but still cool. We'll talk about it, but I don't know if we'll name a stream after it. 3 smooth numbers, those are neat. Got a cube there. This one showed up in my perplexing, I'm mixing the titles up, The Pan-Digital Paradox episode. And, yep, then you get to those ones. And they don't list everything in this range. They could, add some stuff over time, hopefully. But it's hard to find a resource that lists details about numbers of this size. Now, one good website, shout out to whoever designed this, that does have some facts I like to look at sometimes, apart from here, and apart from I have like an actual dictionary of numbers book that's useful, and apart from, I've bookmarked some random places I've found lists of numbers, but one of them that's a good place to search for a random number is this one called Numbers Aplenty. Just randomly found this one day, where if we look up a number, they'll tell us a bunch of stuff about it. Some of the stuff they say is pretty trivial, but a lot of stuff, a lot of facts. So, we have gone past this one, but I actually have some fun facts about the meme number as well. The one that looks like a hybrid clone of the meme number 69, or 69696 here. Well, what can we say about that number? Well, we just said that it's the second smallest we can see here perfect power of any sort that's a palindrome, but which has a root that's not a palindrome. We can also note that it's definitely even based on the last digit, and it's definitely threeven because its digits are all threeven, so they must add to a threeven thing. and 3-even numbers have digit sums that are 3-even and vice versa. So we know it's even in 3-even, so we know it's definitely a multiple of 6 also. But it turns out it has another interesting property. So this one not only is palindromic, but it has a trait that I've seen called undulating. One of the places I first read about this was in this wonderful book, The Wonders of Numbers by Clifford Pickover. He mentioned how this is one of his favorite numbers because it is the largest known at the time undulating, which is a term I'll explain in a second, square. Now, undulating, I've heard other terms for it too. I like that one though. We'll go with undulating. And what that means is it's sort of, in some ways, the closest you could get to what's called a rep digit, which has a single digit only. An undulating number goes back and forth between just 2 digits, one at a time each. So like an AB, AB, AB pattern for the digits. So are they going to call that here the undulating numbers, or do they have a different name? They do. Undulating. Hey, look, they're quoting this book here too. So undulating palindromic primes. That's cool. But yeah, undulating numbers in general are somewhere on here. But there's one list that's extra interesting here, which I already have pulled up. We don't have to find it. Which only has these numbers. The largest number on this list is 69696. And what these are the undulating squares. And all of these are pretty trivial that they have any digits they have in an ABAB pattern, because these have so few digits that we can say it fits it. These are sort of the non-trivial ones that undulate, but are square numbers. And in this book, Clifford Pickover was saying that this was one of his favorite numbers because it was the largest known undulating square. And according to the OEIS, that has now been proven. I assume that's in this paper, which I haven't read, but at some point I'll read that for fun. But apparently it's now been proven. They're here, I think, quoting Clifford Pickover in this book or someone similar saying this. And then they're like, yep, now been proven. They are once again quoting it here. So this book also had some fun stuff about palindromic numbers in general, and another book that had a lot of good stuff about palindromic numbers and just palindromic sentences and different ways of palindromes being used in language or numbers is this Martin Gardner book. So this is just a kind of random collection, a really good one from him, that he's an excellent writer of many articles of recreational math over the years that have gotten compiled into various books. And he's written books, but a lot of them are compilations of his best articles from over the years, and they're just like full of fun stuff. And this one happens to have a nice section about palindromes, palindromic numbers, as well as sentences and stuff. Maybe we'll look at some of the sentence palindromes in there in a bit. And if anyone in the chat wants a challenge, try and come up with a palindromic sentence, letter-wise, so the letters read the same forward or backwards. And we can say, you can have punctuation if you need, we'll skip over that, but mostly go for a sentence where the letters go the same, that involves either Domotro, which might be easier, because you got like something, or to mod, and you know we like modular arithmetic, so there could be a way to make that one backwards in a sense, or combo class, which will be trickier. I don't know how you're going to backwards this into a sensible thing, but let me know if you find any. Now, As far as palindromic numbers, of course, another recommendation I need to make is if you look up palindromic numbers and you go to videos, you find somewhere on there me. Because this was my episode from, like, I guess half a year ago about palindromic numbers. That's super cool. In this episode, we go into things like, what about palindromic fourth powers and fifth powers? We go into things like, what about palindromes in other bases? And we also go into things like, why can't palindromic primes have 4 digits? So that's a good one to see. Speaking of older combo class episodes, there is going to be something interesting I want to share in a moment, but first let me check through the comments. So, thank you all for joining me and looking at all these numbers. And yes, about 666 we mentioned earlier. Some people do find that scary. Unfortunately, it will definitely come up in several episodes because it is a rep digit in our base, has a repeated digit, making it a multiple of a hyper 11. And in fact, it's 6 times a hyper 11, and you know we like the number 6 on its own. So 6 times 111, hard to dislike. Additionally, 666 is a triangular number. In fact, it's one of, if not the, I need to look up the exact details on if it's just one of or the biggest rep digit triangular number in base 10. And so it's going to be hard not to have a soft spot for that one. In addition to the fact that due to some people thinking it's cursed, it has been investigated more over time. And so people have found more interesting facts about it that you can find online than the average number of that size. So like 676 we just saw is cool. It probably has a bunch of other traits that people haven't found or haven't written down online in a clear place. But 666 has been super investigated. So I actually have already made a short for sorry to the 666 haters about a bunch of fun facts about it. And I may at some point in the future make a episode somewhat about it. But we'll see. If we do, we will mention how the truly cursed number is 6 to the 6th hyperoperation 6, which is 6 hexaded 6. And that is putting 3 6s together in a much more cursed way. 6 hexaded 6 is one of those numbers that's almost impossible to conceptualize using things that aren't like hexation, using terms like exponentiation or things that are more familiar. So that's in combo class. The truly cursed number, we're replacing 666 so we can talk about it and have fun with it. It's no longer cursed in combo class. We're replacing it with 6 hexaded 6. So, someone's also noting the sequence 1 1 1 2 1 1 2 3 2 1 1 2 3 4 3 2 1, which also is noted in this palindromic number episode, in that when you square hyper 11s, you get staircases up to a certain size of hyper 11. Someone's wondering, is there a number whose both square and cube is palindromic? Well, yes, but here's how that would work. Well, if we look at the number 101 squared, we get 10201. And if we cube it, we get 1030301. So this number's square and cube is palindromic. How do I know that off the top of my head? Because it's part of a family. I could have started smaller with 11 squared, cubed, or I could fill in any amount of zeros in between those. Cubed, squared. So I'm able to make a number that's 1, a bunch of zeros, and then another 1. And I can square it, and I can cube it. Now this and cubed. And this will make this is putting it in scientific notation at that size, but it will make a palindrome. Now, this family's interesting because it also works for fourth powers, and these are the only known fourth powers of a number bigger than 1 that aren't palindromic. No, that just in general are palindromes, because they are palindromic. There are no known fourth powers of non-palindromic things that are palindromic as a power. But this family will make palindromes, the family of 1, 1, 1, 101, 1001, etc., will make palindromes for squares, cubes, or fourth powers. Funny enough, it doesn't for fifth powers because you get too big at a certain point in there. This is similar to other expansions we'll notice in math. This 14641 thing, and the 1331, and so on. You might notice those in other forms if you put them all in a triangle or something without the zeros. But it breaks at a certain point. We don't have room for it. There's a 2-digit number in whatever triangle you'd create there, and it doesn't work for the digits. So it's actually unknown if there are any palindromic fifth powers. You don't need to make the restriction that the root has to be a non-palindrome or anything. It's just unknown apart from the number 1 or the number 0, if you count those. It's unknown if there are any fifth powers larger than 1 that are palindromic. And as for fourth powers, it's unknown if there are any that aren't in this family. So, for more details on that, see my episode about that, the palindromic one on the main channel. Now, speaking of which, let's see. Someone's saying any number can be written as the sum of palindromic numbers, and there's a very interesting fact about that, which they do list on the Wikipedia article for palindromic numbers. As usual, if you like a topic from one of my videos, see if they have info on Wikipedia, because they're pretty good for their math stuff. Not in terms of having everything, but in terms of, not getting too much wrong compared to like a page they might have about someone's biography or something. And they do have interesting stuff, and it's like a little rabbit hole where you can click around to other topics. Now down here they note something very interesting. In 2018, a paper was published demonstrating that every positive integer can be written as the sum of 3 pandigital numbers. In every number system, this is meaning the basic bases I was talking about, with base 5 or greater. They're basically implying the thing I meant for basic base, because you could invent another number system, but I started nicknaming that basic base since my last main channel episode, because it's way simpler, of meaning a number system that is a base that uses powers of an integer, starting from the 0th power, written left, all the stuff we do for getting bigger, and I mean written left in terms of larger size of parts of it. And the base is an integer number, and it uses digits from 0 to 1 less than the base. That got really clunky to keep clarifying in my episodes, so now I can be like, this pattern holds true in all basic bases. And that will mean that really clunky thing that I said that is technically, getting the details more right in a clunky way instead of calling it a basic base. So there's also a lot more info on here you guys could read about later if you want. One interesting thought here is this is something I'm not going to fully explain, because 2 episodes from now on the main channel, there will be an episode all about this. Not about, this fact might not even come up, but about sums of reciprocals and how some of them converge to certain values. There are so many cool ones to mention that I literally think it's likely this one won't show up in the episode. So, to anyone who wants a bonus fact now, the sum of the reciprocals of the palindromic numbers, I'm assuming they mean in base 10, is a convergent series whose value is approximately that. Now, I would like to see the values in other bases, and I don't think too much data has been put into that, but maybe I'll poke around more sometime. So, since we're on the topic, I just filmed the next episode coming out on the main channel. That's a fun one. It's a mix of math and language, sort of, because it's about weird traits that emerge with spelling numbers. Using English, the one I know, as the example language, but patterns will emerge that, we can think about in general the capabilities or limits of a language being able to express names for numbers. And what weird traits will happen if we start doing things like making lists of them alphabetized or looking for certain letters in them. Well, very interesting, actually. A lot of fun facts there. And so that one will be coming out next. Also, in a couple streams ago, or maybe one stream ago, I asked the viewers, what do you want to see at the beginning of the episode? Because we want to put something fun and attention grabbing for all of the people to get tricked into learning all of the math and language stuff that I want to teach. So people, instead of fire or precarious stack of clocks or things like that, voted for cats. So my cats will be in the intro and the outro of the episode. There's still a lot of falling whiteboards, but in the very intro and very outro of the episode separately, those will be in my front yard or living room with my cats. I got a shot with all three of them, at least for a bit, because there are 3 cats now, counting the stray one. And maybe we'll get a visitor one, because, the window's open for that reason. And someone's saying I may have misspoke and said pan-digital when it means palindrome. If I was saying pan-digital on some of those, sorry, I do mean palindrome for all the stuff I was saying this episode. Wasn't really talking about anything pan-digital related this episode. I meant palindromic for all of it. I get confused because the 2 episodes on my main channel that were about palindromes and about pan-digital numbers, both of those I used a lot of alliteration. So in my head, I'm like, wait, pan-digital paradox or perplexing patterns of palindromic numbers? And so I get those mixed up. There's just a lot of P type of numbers in maths, like perfect numbers, perfect powers, primes, primorials. What are all the P's? You got palindromic. There's a bunch in one of these episodes. There's one called persistent numbers of various sorts of that word. There's ones called the 2 that I was mixing up, definitely. Now I'm mixing them up in my head again. But yeah, pan-digital and palindromic. So all of this episode or stream was about the palindromics. So, thank you all for joining me here again. And what we're going to look at now, after finishing the quick note, which was that after the language episode, there will be this episode, which is about sums of reciprocals, not about palindromics, but various sorts of sums of reciprocals. That one will be wild and crazy and cool, and it's going to be the last math one of the grade. After that, there will be a really long, wild finale that will be more like a behind-the-scenes or philosophical or documentary type thing. So some of the reciprocals is sort of its own grand finale in terms of mathematicalness. Now, when the finale comes out, the finale will include a lot of fun scenes. It will involve probably something involving my haircut or beard cut that is inevitable. Probably something involving the final destruction of some of the things that are 90% destroyed in the classroom. Probably involving, I might camp out in the classroom in a tent for a night or two to see if there's any cool nighttime creatures or anything. I also have some glow-in-the-dark spray paint I could test out then. I also will take a field trip in the finale to a clock-related fun thing. I also will be writing down all the names of my Patreon supporters on a whiteboard when I'm thanking them, and maybe thanking, along with some cameos, some of the people who helped me out on the grade, such as camera people. And there will be some cat footage and other wild footage. And there's going to be some discussion of how in grade -1 I had to get 2 intense surgeries. And I'll show you x-rays and stuff. And that was crazy and wild. And in some ways it'll be a lot easier for me to make grade -2 than grade -1, because I'll be able to walk fully instead of limping around during much of it behind the scenes. So there will be some stuff about that as well. Then grade -2 will be coming either on April 1st or shortly after. And when the finale comes out, maybe 2 weeks or a week before that, there will also be an optional, something some people have asked for that some people will hate the sound of, but bear with me, I would hate the sound of it at first too. There will be an optional final exam. Now, why is there going to be a final exam? I'm not the type who likes tests. I did pretty good at tests. I was good at test taking throughout school, but I've never found them to be a measure of someone's intelligence. And sometimes you have a huge grade or something dependent on it in a completely imbalanced way, where, you know, how good you do at being on the spot with a certain type of memorization in a 1 hour span can be more important than all the work you can or can't do over many other hours. So tests are not really a measure of someone's worth, and they are overweighted in society. However, when a test comes, you do get something good, which is, if it was a subject you wanted to learn, it forces you to check, did I actually know all the main stuff? Can I actually figure out extensions of the main stuff, like other examples of it myself, when I'm actually put to the spot? Can I, when I get the test back, how can I improve on the things that it turns out I didn't understand, that I either got wrong or didn't know how to do? And so, for people who want to see if you really learned some of the core mathematical stuff in the grade, or as just a fun challenge to build your brain, it will be an open book test in that you probably won't need a calculator. I'll clarify if there's any bits you will. But if you need, you can use a calculator for simple arithmetic. If you don't remember something, or you don't think you've seen an episode of something, all of the test stuff, all the answers will be answerable with a mix of problem solving, simple arithmetic, and something that was said on the main channel. Probably stuff that was also said on this channel at various points, but all of it will have definitely been covered on the main Combo Class channel's full episodes. So if anyone wants to prepare for this test, you can always watch some of those and try and get some core concepts out of them. Now, let me actually make myself big for a moment so I can look at a document here. And what I'm going to look at real quick is just an example of, I have a document of some questions that I was preparing, and an example of some things that could be on this optional test, which is really good for your brain, because I highly recommend people try it. It's, even if you don't do the whole thing, just see what parts of it you can do. I will give the answers like a week later in a video. And I highly recommend it because a lot of my videos feed you facts, and it's the way I got a lot of these facts, in addition to reading a lot, was fiddling around with numbers myself. So it's good for you to do that as well sometimes too. If you like number facts, play around with numbers yourself. Or same things with science and such. Since there was so much math in grade -1, future grades may have more science and other types of stuff. but there was so much math in grade -1, almost all of this test will be math. But there will be a couple questions about other things like botany or so on. Now, examples of questions might be being given a number and a few bases you have to write its expression in. You might be given a type of number and have to provide an example of a number that's that type. You might be asked, in a given base system, what certain traits would be for a certain type of number, or how many of a certain type of number there would be in a given size range. You might be asked, let's see, certain things that require you to take some piece of knowledge that was given in the main channel and often also clarified in other videos, but definitely covered in the main channel, mixed with having to do at least a little bit of calculation yourself. So most of them, when possible, I'm going to design to not just be something that if you see a part of an episode, you know what the answer is directly, but more so if you see a part of an episode, you're like, okay, now I pretty quickly know how to figure out the answer. Some of the things, of course, won't work like that and will just be, what is an example of this type of number, or something like that. There will also be extra credit, which will be more like, you know those old puzzle books called an I Spy? People compared my video set to those sometimes, where there's a lot of hidden clues. I did that on purpose. Not like I Spy books in particular on purpose, although I do remember those from childhood and loved them. But I filled it with clues on purpose. And so there might be extra credit questions, like, where is a moment where in the background so-and-so happened? Or how many times has certain rare thing happened in the background? Those would be extra credit. So that will be an optional test that will be coming out along with the finale. That will be our final exam for anyone who wants to challenge your brain more so than just getting fed all of the facts, and see if you really understood some of my favorite concepts that we learned this grade. So, to anyone who wants to do that at any point in time, you can always just, not watch the answer video until at some point when you've watched most of the main channel episodes of grade -1. Then at some point you give a shot to which of these questions can I answer. And if you really don't want to, then you can watch the answer video where I will explain through them. But it'll be good for your brain if you do it. So, someone's wondering if I can predict the Bitcoin, I think is those initials, price using advanced mathematics. If you studied a lot of statistics, you could have better guesses, but you'd also mostly need to study economic factors that aren't pure math, that relate to, in this moment, what certain things are happening in the real economic world. So it would almost be more like history on a really quick scale sense of history than math you'd need to know, because you'd be using math, but you'd need to feed a lot of data about the current market of various things. So people have tried. Sometimes they've made a lot of money from it, sometimes they haven't. Still a gamble. That's not something I've studied because I would have to, it's not really pure math very much. Someone's saying, can I do the pi circle in graph? I don't know what you mean by the pi circle in graph, because I could graph a circle, but what's the pi circle? I mean, all circles have pi hidden in them, sort of. So, I will graph a pi circle, sure. Let's shrink me again. And we can graph a pi circle. Oh, whoa, this is what's already on there. So, okay, we're going to get to that after we graph a pi circle, unless that's what you meant by a pi circle. We can graph x squared plus y squared equals 1. And this circle has a circumference that is pi times more than the diameter. It also has an area that is pi times more than the radius, because 1 squared is the same as 1. So, someone's wondering if I've watched Breaking Bad. And I have, actually. That's a good show. I don't watch many shows, but since I kept hearing that one recommended back in the day, that's one of the few drama shows that I've watched all of. It is good, but I barely ever watch TV, so that's actually like one of the few ones I've watched out of, say, drama shows. Now, someone's mentioning something that looks like the reciprocals of the squares of primes, and they're wondering if that maybe will show up in the reciprocal episode or something. There will be definitely reciprocals of primes and reciprocals of squares. There might not be that mix of them right here in the first reciprocal episode, but lots of things will show up in the future. The first reciprocal episode is actually, in a way, its own awesome episode I've been planning all grade, and in a way, the first part of a future episode to set up an episode about the $1 million Riemann hypothesis. So, as Wikipedia might describe it, let's see what they describe it as. What they're going to say something about this is something along the lines of, the Riemann hypothesis is a $1 million question. You get $1 million if you answer it with a thorough enough proof. And it's asking whether all of the non-trivial, meaning not on negative even integers in this case, zeros of the analytic continuation of this thing called the Riemann zeta function on the complex plane are all on the line x equals 1/2. So it sounds really random, but you get $1 million if you answer that. So by x equals 1/2, that's basically, since that's the real one, they describe it as real part 1/2. And this would be fun reading for anyone who wants, but I will explain this one at some point. There are actually multiple $1 million questions. There's actually more than just these ones, too. There's at least an 8th one called Beal's conjecture that also has $1 million prize. But all of these have $1 million prize. You got Birch and Swinnerton Dyer conjecture, Hodge conjecture, the Navier-Stokes existence and smoothness, the P versus NP problem, the solved Poincare conjecture, the Riemann hypothesis, and Yang-Mills existence and mass gap. So some of these are almost half physics questions and half math, like they work with applied math, at least this one. Then this one's an incredibly complicated, well, not really complicated in its question as much as people aren't sure if we'll ever answer it, computer type question about what algorithms could do what. And these ones are confusing. This one, you need to know, like, talk about 4D topology and stuff. And the Riemann hypothesis is, out of these, probably the most understandable to fully understand what it's asking, or maybe P versus NP. And the Riemann hypothesis is definitely the one I am most equipped to explain at this point, but that'll be an early grade -2 because it is an infinite series, essentially, that it's asking about, the Riemann zeta function. And so some of the ones we're going to cover in this episode first, about infinite reciprocal series, at the end of it we will point out are actually little slices of the zeta function, which is a more generalized version of some of them. So that's going to be a fun one. Someone's asking if Desmos is better than GeoGebra, and I haven't tested GeoGebra enough to know. I actually think GeoGebra might be more advanced and have more capabilities, but I'm not positive. I will test them out more in the future. I just know Desmos is really easy to figure out from a tech standpoint, and although it's relatively simple, Like GeoGebra has a better chance of 3D type stuff. Desmos is very simple to figure out from someone like me's perspective, where I'm not really a tech guy. And so I don't want tech stuff in the way of me having an idea. I want to try graphing it. And Desmos has very little in the way. It's a very direct, simple to figure out calculator like thing. GeoGebra is a little weirder when I messed around with it, but I probably will explore it more because, if anything, it might have more advanced capabilities. So, with Desmos, we did have this crazy thing open that I want to show you real quick. So, I have an equation on my wall right there that is, we wrote it on the stream. It's this one. We wrote it on a way previous stream. I wrote it on the wall because it was so cool. And it's this without the A, which essentially means if A is set to 1 here. Because if A is set to 1, it's not there, basically. 1 times it. And if we have 0 here, let's note that this whole thing becomes 0, if that's 0. Same with here. These are the same, except that one of them has multiplication and one of them has addition. So here's the multiplication one at 0. Check it out. We have a perfect checkerboard. And it is pi across. So when you asked for the pi circle earlier, if you were asking for the pi square, here you go. This is the pi square. Well, the pi square grid. Now, if I really wanted it to have a radius of 1 instead, interestingly, by sticking pi's in here, I like neutralize that. And now it's like canceled out and the grid is 1 for its size. But let's take those pi's out for now. And let's raise this a little. So what's going to happen when I take 0 to something slightly higher than 0? Whoa. Looks kind of checkerboard-like, especially if you're down here. Still looks pretty checkerboard-like. However, is it? Oh, wait, am I still on? Do I have this shrunk right? Yeah, I have this shrunk right. Thank God. I had a little, like, brief moment in my head where I was like, oh no, am I doing one of the things I do sometimes where the camera's just on me and I'm talking about a graph for 20 minutes? Okay, no, you're seeing this. So it looks checkerboard-like, but it's starting to break. And we can make it break more. Ooh, we got this little infinity-like thing in the middle for a moment. And I wonder if we flipped X and Y, if that would be this orientation of infinity. Yeah. Look, I got a little infinity fella there. And it might be clear if I turn that to an equal. Yeah. Look. Little infinity hanging out on these weird threads of something. So that is just an insane graph. This is just literally just the graph. And this part it's having trouble calculating, so it's like infinitely dense in that part. But this is the graph of just sine of x times sine of y equals sine of 1.5y over x. Sounds surprisingly simple of an equation to be this crazy. So now we're going to go back to inequality land, and we're going to raise this a bit. So we're getting different types of ripples coming out. And whoa, this looks like these infinitely falling walls almost. You can see like a 3D illusion of a corridor or a tunnel or something like that. Doesn't this look kind of like a 3D? You're zooming in there. You want to go into the tunnel? Whoa. Well, that doesn't help the illusion much, actually. At one scale, it looks crazier. This is how we go into the tunnel. Whoa. All right. We can also see there's weird stuff going on these ripples. They have like almost straight square-ish parts to them, and then they have these really ripply parts. Also, when we're at some stages of it, some parts of it over here, if I get to the right level, let's see. Some of these phases... Maybe it was the other one I was thinking about. Let's go to the other one for a moment and see what I'm talking about. So this was our multiplication one. We can do an addition one also. This is it when it's 0 there, and this is it when it's slightly more than 0. Now, this is the one I was thinking of, where when it's at certain stages, it looks like a maze. It looks like you're like, okay, which way do I go? I'm going to go over here. If you go over here in the maze, you're like, What about this part of the maze? Can you even get there from the same place? A little around the maze. And I wonder if you could get a graph that would actually give you, like, more of that where you had a solvable maze of any sort. Wouldn't that be super cool to find, like, a maze here? Like, imagine... If you're like, okay, which way do I go? So, maze graphs. That's a new thought. All right. Now, if we want to be really crazy, let's put this X and Y back together and let's try and overlay them. Whoa. So this is with the high level of A. Let's go down to 0. Okay, that looks neat. We got this little grid on grid, and then let's mutate it a little. Whoa! And look at that. This is a crazy landscape. Whoa. Now what if we make it a little larger? Okay. Pretty wild, huh? It's cool when it's at that full stage, but I think it's even cooler when it's at a not quite full stage and you can see these different rays emerging. Something like this is the wildest, because look at all these different regions you get. Whoa. Alright. And just for fun, this is the inequalities where it's less than the right side, but let's see what happens when they're equal, because this is in a way more pure. These are all the coordinates where sine of x plus sine of y is sine of this slider times x over y, or where the same thing is true but with a times sign there. This is crazy. Alright, now even just one of them looks really cool. There's that one, and there's that one. So, hard to believe that such a simple equation makes such an insane landscape. Wow. I also like this thing running down here, like, it's getting like more and more askew, and it's sort of wanting to become a square. I'm trying to be the side of these squares. By the time you get down here, it's doing a pretty good job being the side of these squares. And then what does it do on the other way? Up here, it's like, whoa, and it got caught into this crazy river. So, that's pretty wild. Okay. Someone says it kind of looks like a fractal. I think we could call it a fractal because as we zoom in, there is new detail at an arbitrarily small or large scale. And so, not all fractals have to have the trait of self-similarity, although that is, you know, a landmark common feature of them. And since there's different stuff in here always, in some ways I think we could call this a fractal. We'll do more episodes about fractals in the future because, you know, it's cool. With certain types of fractal, you can categorize them as having an in-between dimension by certain ways of stretching what a dimension means. Not even a super stretch, a mild stretch. And by mildly stretching the definition of dimension, you can categorize shapes that have dimensions between 1 and 2 or between 2 and 3. And we'll get into that. Super cool. So this is wild. So, leave any other thoughts or comments in the chat. We are transitioning now maybe to just a little bit of chatting now that we have already given our shout outs to how of these special numbers. I lost one of those OEISs. 676. This is what's great about the OEIS. This is how you find cool stuff. So, on this list of the perfect powers that are palindromes in our base while M's not a palindrome, we just got this little fella, the largest undulating square, proven now apparently, that also happens to look super memey. And the number we just passed in subscribers, that is the only attainable subscriber amount that is a perfect power and its root is not. So, after this, one thing I want to note is, so it's been raining out there. It's also been winding like crazy. The wind was going absolutely mad. I'm going to make myself big while I talk about this. And it was knocking over all sorts of stuff in the combo classroom. And see if you can spot any like weird wind-like things that happen in any of the shorts I put out recently, or that I'm going to put out, or in the next video that's going to come out on the main channel. Because the wind, sometimes I would have a whiteboard set up, and without even like needing to touch it, it would fall over. And so the whiteboards are just like falling left and right. And the wind also knocked off a giant branch from my next door neighbor's tree over there. Not the neighbor next to the combo classroom, the neighbor on this side next to this window, which is a different side. And they have these redwood trees. And this giant branch fell out there. And maybe I'll show it to you for a moment if it doesn't mess up the camera, because we can see if we want to use it in the combo classroom as a decoration, or eventually if it's dry enough to be firewood or something. But check out this big thing I might put in the combo classroom because it just fell outside my window. 1 second. I'm going to put you folks on this for a moment so I can relocate this briefly. Oops. All right, check this out. You see this giant branch? So, that's not supposed to be falling off either. That's not good. So, that may be a decoration in the combo class soon, because who knows. 1 moment. Okay. And that might be a nice little decoration for toward the finale. We're going to need to decorate the classroom a little bit after cleaning it like crazy and getting rid of a lot of stuff. Unfortunately, some clocks are going to have their final shots and then get thrown away because they had wooden parts or cardboardish parts that got super moldy. So some clocks are going to get tossed. Some also got their front glass part shattered and are going to need to see if we can salvage or not. And a lot of the whiteboards, all the mini whiteboards I had are soaked, so you barely need to like press them and they just snap. Some of them are snapping on me accidentally. And we'll do those destruction rituals, and then grade -2, like I've hinted, there will be modular resets where if you look back at the first episodes of grade -1, I might look mildly like that in a few months. Of course, I'll look older and I will look different, and the classroom will have certain of its evolutions kept, like some clocks get to stay because they're still survived, and there'll be new clocks too. And the dice will still be in the ground and such, in the dice carpet. But there will be some fresh stuff, like a new desk and possibly a new lab coat. And then when I have guest people work with me, I will make them wear this lab coat for safety. Or if I ever do something dangerous, I can wear 2 lab coats at the same time. So that'll be fun and upcoming. And I'm not going to stream for a crazy amount longer. I might put some other sort of bonus content out later today, or if not, I will definitely be editing that new episode I filmed yesterday, and definitely make sure all of you have caught the latest episode on the main channel just a day or two ago, which has base 1010 in the title, although that's just a small shred of some of the base stuff we go into. It's one of the base episodes, but not about some random singular obscure bases, about bigger scale patterns on all the integer bases looked at from afar. So all of that is in the video description, I believe. I'll also put timestamps of the stuff that happened in this stream when we discussed what, to a degree. So you can look for that, and it'll be done within, half an hour after the stream or something, if you want to rewatch any bits that you missed earlier in the stream when we were talking about math or stuff like that. And if anyone has any comments or questions, now is a good time to leave them. I also, before I check the comments, will do my obligatory mention of the stream that there's a lot of cool bonus content on the Patreon if anybody wants to help support there. And you will also get your name on a whiteboard in the grade -1 finale when I am thanking people. So, someone's wondering about a different infinite family of operations. Like how there's a sort of hierarchy going from plus or times. Yeah, that's a good question. There are other possible operations. You could try and see which ones may be able to be extended into hierarchies of their own. Let me know if you find anything with that. I'm not sure. It's a good question. So, thank you all for joining me. I will be ending this stream soon, so we didn't get any cat meows, unfortunately, but there will be those in the next main channel episode, which, since I just put one out a day or two ago, the next one will be coming out in a little under a week. Probably in 4 or 5 days, but I'll be doing a lot of stuff on this channel in the meantime. We're going through some cool transitions right now because I only have 1 more week of teaching music lessons to private students. And then in March, it's just combo time. So, I will be able to have more concrete, particular streaming days to the people who were randomly around for this stream live. I was doing this from when my time, it was 8:30 to it's almost 10 now. And so that's on the earlier end, but I might do early-ish ones like this, or maybe starting around this time on 1 day a week. And then there'll be another day a week when I have them in more of my evening. and a bunch of random ones in between whenever I have time. And there also will be a lot of other fun stuff, including, for those who didn't manage to catch, the new mailbox that I got, which the keys are right here, but I'll keep them in my hand there. These are the keys. I'm not worried about people seeing them like some people were. But packages will be pretty much behind a counter and need signatures anyway. But if you have anything you want to mail me, I will be able to get it from this new private mailbox that's now my address. And look around your house if you got any old clocks, for example, or calculators or dice or things like that you don't need anymore. And if you send them to me, then they'll probably appear in the background of some episodes. And in this description, I do have the address for that, but I also have a link to a short video you should watch first. That's just like 3 minutes of a few guidelines. But some of you should try that out if you want to see your stuff show up in the background of grade -2. And grade -2 is just about a month away. Barely more. So, we got one graph request. We'll do our graph request and then we're going to wrap up. Someone wanted to see cosine of x squared plus y squared equals 1. And they're having trouble with that. However, there are variations that we can do that are really cool. Well, sine isn't going to help either, but if I put the sine around them individually, that's on my wall. Sine of x squared plus sine of y squared equals a squared. Let's put a squared here so that we can try a few. We have a there. And this is basically just putting signs around the individual components of the left-hand side of a circle equation. That's why I have a squared on the right. Really, we can call it a. But now it's, like a different form of the circle equation. And we're going to say plus sine of y squared. And check it out. That's when it's 0. This is when we go a little further. And this is one of the cool states, for example. All of this realm is that really simple equation, the circle equation with signs on part of it. And this part right here is just them messing up. And we can mutate it in different ways. So that one's pretty cool. And of course, if you replace it with stuff like tangents, you also get insane stuff. And some of these have been in previous streams, so we will end it off with this more new one, which is this insane combo. Whoa. A lot going on there, even just with one of the two. There's one. There's the other. So, thank you all for joining me. We are going to end our stream here. But there will be more forms of content either today or tomorrow on this channel. So I'll see you again very soon. Hope you have a good day, and if you want to catch me further, you can check out the links such as the Discord and the subreddit and the Patreon.